different mechanical tests. Okay, so we have started with the destructive testing. Okay, so ito po yung second part, which is the NDT. Okay, so ano po yung tinatawag natin the NDT? This is called the non-destructive testing. So this one is a process of doing inspections, testing, or evaluating the materials, components, or assemblies for defects without destroying the material or the component. Okay? So yun po yung main difference niya with the destructive testing. Okay? Destructive testing will mean destroying the material or the component for you to come up with those properties. Okay? So yan po yung ginawa natin. Say for example, on the tensile test, you need to see the failure of the material. You need to break the material for you to find out the value of the uh, property. Okay? So, dito po sa NDT, hindi po natin kailangan iyon. Okay? We simply do some inspections. Okay? We do the testing. Okay? Tapos, i-monitor po natin. And from the data of the testing and the monitor that we have, dun po tayo magde-derive ng conclusion as to the properties and the defects of the material. Okay? So, ganun po ang ginagawa dito sa NDT. Okay? So, in other words, this is simply inspection or measurement without doing harm on our material. Okay? So, yun po yung ginagawa kapag NDT. Now, who uses the NDT? Okay, so these are the industries that utilize the NDT. You have here the airplane and the aerospace, automotive and railroad. You have here construction, hydroelectric, fossil and nuclear power, textile and manufacturing. We have chemical and petrochemicals, logistics and supply, medical and pharmaceutical. Okay? So later po, sa later part po, yung mga slides po sa padulo, okay, will tackle on the specific application of the NDT for the following industries. Okay? So halimbawa po, you have the automotive. Okay? So mamaya po makikita natin ano yung specific na application on these industries. Okay? So if you are to evaluate on these industries that utilize NDT, these are the same industries po that make use of the deterrent, okay, yung destructive testing. Halos parehas lang po. So, magkaiba lang po sila ng mga areas, okay, na kinukonsider yung mga testing po na ito. Okay? So, what are some uses of NDT? Okay, so the first one is flaw detection and evaluation. Okay, when we say flaw detection, so na-locate po natin, okay, yung mga surface discontinuity, yung mga flaws. Okay, so samples are yung cracks, okay, you have the blowholes, okay. So yan po yung mga sample ng flaws. So from the testing that we will make, from the NDT that we will make, nakikita po natin yung size, yung shape, okay, and orientation of these flaws. Okay, so maaari po kasi sabi natin ay maliit lang yung ano na yan, yung crack na yan, but then deep inside using the test, you would observe ay malala na pala po siya. Okay, so with the testing that we'll have, the monitoring and the inspection, we could see the degree or the severity of this surface discontinuities. Okay, and kung ano yung posibleng failure na ma-create na on the material. Okay, next one we have their leak detection. Okay, so when we say leak detection, okay, kahit hindi po natin nakikita, from the data that we obtain, ay makikita po natin na that there is really a leak on the system. Okay, so base saan? Halimbawa, you conduct the pressure test. So nagbabago yung pressure niya. So this is a manifestation that there is a leak on the system. We have also location determination. As I have said kanina, okay, hindi mo nakikita yung butas, hindi mo nakikita kung nasa yung leak. At then, base sa ginawa nating testing, okay, you are able to locate nasaan po ba yun and be given appropriate rectification. We have here naman po dimensional measurements. Okay? Alin po yung dimensional measurements? Halimbawa po is the degree of yung thickness ng corrosion that the material has, okay, or yung component na meron. So, gaano na ba kakapal yung ano niya, yung corrosion niya. That would, of course, makaka-apekto doon sa performance at mag-cause din ng failure on the material. Okay? So next would be structure and microstructure characterization. Okay, so when we say the structure, the microstructure, we are after the arrangement of the atoms for a specific material. Okay, so using the NDT test, okay, we do the characterization and then we can see nasan ba yung mga defects on this structure. We were able to see the vacancy, yung mga interstitial, and any other point defects or um, linear defects. Okay? Katulad po ng mga diniscuss natin last time. Okay? So you have there. Okay? Makikita po iyan through the NDT. You have estimation of mechanical and physical properties. From the word itself, estimation. Okay? So bakit po estimation? Okay? From our DT, okay, so destructive testing, we are able to define the ultimate strength of the material, the yield strength, the breaking point. Okay? Dito po, pwede rin naman magawa using the NDT. Lamang, it is simply an estimation and not the real value. But the value is close enough to the real value obtained from the destructive testing. Okay? So, ginagawa po ang NDT to determine these mechanical and physical properties kahit po estimation lang yun nakukuha. Why? Diba sabi nga po natin, it is ideal to use the destructive testing only when you have mass production. So, kung limited lang po ang number ng units na ipoproduce natin, hindi po yun advisable na gawin. Okay? Kasi talo ka po doon sa gagastusin mo. Okay? To determine those mechanical properties. Okay? So, as an alternative, you can do the NDT. Okay? You will get a close approximation of these mechanical and physical properties. Okay? Likewise, on the stress strain diagram and dynamic response measurements, okay, ang makukuha rin lang po natin dito is mainly an estimation close enough to the one obtained using the destructive testing. You have their material sorting and chemical composition determination. Okay? So here you are able to identify ano po yung mga alloying elements in the material and their specific percentages. Okay? That is using the ND. Thickness, hardness, and the conductivity of the material. Okay? So these are obtained also using the NDT. Halimbawa po no, thickness ng material coating. Say for example po, we have our wires. Okay? Yung wire po natin, electrical wires. So yung conductor po, nandun sa gitna. And then nakabalot po siya with an insulation made up of plastic. So yung insulation po na yun, yung coating po na yun, yun po yung chine-check natin, okay? Do they have yung the same or uniform thickness all through? Okay? So, dapat po, uniform po yun. Okay? Dapat po, nasa gitna siya, tapos nakabalot siya appropriately. Hindi po pwedeng nakatabi kasi that could possibly cause an incident kasi more prone po siya to rubbing o kaya po ay friction. So, ano mangyayari? Matatalo ka kung hindi po siya pantay yung pagkaka-coat po sa kanya. So, that is being monitored using the NDT test po. Yan. So, when is NDT used? Okay, so there are NDT applications that almost any stage in the production or life of a component. Okay, they're just used to assist in product development, to screen or sort incoming materials, to monitor, improve, or control manufacturing processes, to verify proper processing, such as heat treating, to verify proper assembly, and to inspect for in-service damage. Okay? So if you are to take a look on the uses of this NDT, the verbs that are being used, ano po ang mapapansin natin? Mainly to assist, to monitor, to verify, to inspect. Okay? So, ibig sabihin po niyan, okay, ang nakikita lang po natin, this is mainly inspection, monitoring, conducting the test, and obtaining the data. Okay? And from this data, you evaluate. Okay? And predict what are those, okay, properties of the material, kailan yung failure, base sa mga nakuha po natin na data. Okay? Katulad nga po ng sinabi kanina, it is simply inspection, okay, without doing any harm on the component. May question po ba tayo? May question po? You raise your hand na lang po if you have. Hello?
Wala naman po.
Okay, good. Okay. Thanks. So I'll proceed now. Okay, let us have this a slide. Okay. So NDT test method may be used to determine una, size, shape, and orientation of a flow. Okay. So for example, using the NDT, you're able to see how big is the crack. Okay, what is its size, shape, orientation, gaano ba kalalim. Okay, maari po kasi we can see on our naked eye, ito yung laki noong atin na crack. Okay, but then deep inside pala, there is this propagation of the crack, okay, na hindi po natin nakikita, okay, which will cause, okay, failure on the material, okay. So using the NDT test method, so nakikita po natin yung degree or yung severity nung atin na surface discontinuity. Next one is the thickness of a material or coating, just like po yung sinabi ko kanina on the coating of your electrical wires, okay? The hardness of a material composition, and the electrical conductivity, okay? So, ito naman po yun din nabanggit ko na po kanina. Okay, so these are the types or the samples of the NDT methods, okay? So we have the acoustic emission testing, okay, which uses the sound wave, okay, to predict yung atin na flaws on the material or surface discontinuity or defects. Next, we have the liquid penetrant testing, okay, which uses specialized fluid to detect the flaws. We have also radiographic, okay, so similar to the X-ray machine. We have the vibration analysis, visual testing, leak testing. So ito po yung mga samples po natin, okay, of the NDT methods. So next to this are the 6 most frequently used test methods, okay? So ito po yung i-discuss natin, yung po pinaka-malimit po natin na gamitin or i-apply. So, ito po yung pinakamalimit na i-apply, okay? So, ito po yung mga common na ginagamit nila since this is not so much expensive, okay? So, let us have the visual test. Okay, we have the liquid penetrant test, magnetic, ultrasonic, eddy current, and the X-ray test. Okay, let us have the first one. We have the visual testing. Okay, so when say visual testing, okay, you will be using your naked eye to see the defects on the material. Okay, so visual observation of the surface to evaluate the presence of surface discontinuity, such as the corrosion, you have the cracks, the misalignments, okay, blow holes, etc. Okay, so these are most commonly used method in the industry, as other test methods, okay, they go hand in hand with this testing, okay. So kasama po yan palagi sa lahat ng mga test methods po natin na i-conduct, okay. So lagi pong kasama yung visual testing, okay. So this can be done simply by direct observation on the component or material po na ini-evaluate natin or tinitest po natin, okay. So you simply look directly using your naked eye. Now, if there are cases that hindi naman po natin masyado makita, okay? So this may involve the use of optical instruments such as that of the magnifying glass, the mirrors, and we have there also yung viewing robots, okay, to do the job. Okay? So, in that case po, pag nakita po natin na na-measure po natin gaano talaga yung laki or severity, yung size, yung shape ng ating mga surface discontinuity. Okay? So, pag nalaman po natin yung mga surface discontinuity na yan, halimbawa po, meron ka nakita na crack. Okay, base sa size ng crack, sasabihin mo, ay, masisira yan, pwede yan masira after 2 more uses, masisira na yan. Kasi kaunting-kaunti na lang. Okay, ang laki na kasi ng crack. Okay, so, base doon sa size, doon sa shape, okay, yung orientation po ng crack na mga or other surface discontinuity, you're able to predict, okay, the life of the material. Okay, you're able to obtain the properties of the material. Okay, so yun po yung ginagawa natin. We simply do the inspection, okay, we monitor its performance, we take data, and from this data, doon po natin ngayon ginagawa ng analysis and conclusion as to ano ba yung mga defects of the material and yung mga properties ng material po na iyan. Okay, the second one is the liquid penetrant testing. Okay, so ito po kasama din ng visual inspection. Okay, there are cases that using the visual inspection, hindi natin makita yung degree ng severity ng surface discontinuity. Kasi nakikita natin ay sobrang pino lang na halimbawa na crack. Okay, or hindi natin makita yung crack sa sobrang liit. Okay, so para po makita natin really and ma-measure natin kung gaano talaga iyon kalaki, we make use of this liquid penetrant. Okay? So, it is simply a liquid with high surface wetting characteristics. So, ang ginagawa po doon, it is applied to the surface, okay? And then let the liquid seep into the defects. Tapos po, yung labis po na fluid, yun po ang atin na i-remove. Okay? Pero, it should penetrate doon po sa atin na defect. Okay? Para mo mapasok niya lahat. Tapos ano po niya, makita natin through the UV light po kung gaano yung intense or yung intense no defect na meron po siya. Okay? So, it will then be exposed to UV light para po iilaw po yung atin na liquid na nag-seep into the defects of the material. Okay, so in that way po, since may kulay siya on the UV light, you can easily measure, okay, gaano yung size, yung shape at orientation ng flaws po natin. Okay? So again, it goes hand in hand with your visual inspection. So makikita lang po natin ng mas maayos if we make use of this liquid penetrant. Okay, so the third one, we call this the magnetic particle inspection. Okay, so ito naman po, applied doon sa mga pipings or tubing. Okay, so when you inspect po, halimbawa itong tubing natin or piping natin ito, from length 0 up to yung final length, okay, yung all throughout the length of your piping or tubing, atin po yung iti-test or i-inspect, okay? So, you start with, halimbawa, doon sa pinakadulo. So, you run po this equipment, okay, made up of magnets, okay? So, you run this equipment inside po or outside, and then meron po siyang sensor, okay, referring to the flow of the magnetic flux, okay? So, ano po nangyayari, okay? This would be the result, okay? Nun pong atin na testing, okay? So, ito po yung sinasabi, sorry. So, ito po yung sinasabi natin na data. Okay, so ito po yung sinasabi natin na data. Wherein, this is the result of your test. As you run down po yung ating equipment doon sa surface, makikita mo po itong representation nito on the screen. Okay? So, ito po yung data natin na sabi ko ay ating titipunin to determine ang defects po on the material. Okay? So, mapapansin niyo po dito sa pinakailalim, this is the flow of magnetic flux. Okay? So, ito po yung magnetic flux natin. And as you observe po, okay, so constant flow lang po ang meron tayo. Okay? But then above this, on this part po, nagkakaroon na ng fluctuations. Okay? Nagkakaroon na po ng surface discontinuity. Ay, hindi po katulad nito, this is such a natural flow. Okay? So, pag nagkakaroon na po ng discontinuity, okay, or yung turbulence on the flow, okay, ano po ibig sabihin yan? Yan po yung parte na meron po tayo na okay, yan po yung part na meron tayong crack. So, we can easily identify, okay, ano, ito yung buong length ng iyong piping. Hindi mo alam, saan ba may crack dyan? Saan ba may defect dyan? Okay? So, using the obtained data, makikita mo, ay, may paalon-alon doon. Okay, bakit may paalon-alon doon? Kasi nandun po yung defect. Okay, so halimbawa, yung paalon na yun refers to this part. Okay, so ibig sabihin, nandito po pala yung atin na ano yan, na mga discontinuity na yan. So we are able to locate. Okay, so this one naman po would be a combination po ng ating liquid penetrant and the magnetic particle inspection. So kung ito lang po yung ating mga component, ay pag merely looking at it, parang wala naman pong mali or wala naman pong defect po siya. Okay? But then when you expose that to a UV light, okay, so ano pong nakita natin? Ay, meron pala siyang crack doon sa parte na yun. Okay? So, ibig sabihin, failure would most likely to occur on such area. So, pwede pala itong mag-react kasi nandito po yung crack po natin. Pwede po yun yung pagsimula ng failure ng ating material. Okay? What about this one naman po? Okay, so you have this hook po. You see there po yung kanya na defect. Okay? So with this defect, ano po posibleng mangyari? Failure would most likely to. Okay? So yun po yung sinasabi natin, okay, na gamit ng ating NDT. Sorry. Mali ako. Okay, so this is the next one. This is called the geography. Okay, so ano naman itong ginagawa with this NDT? Okay, so basically this is the same as that our X-ray. Okay? So, parehas na po rin ng X-ray. Ang pinakaiba lang po is, sa X-ray, tao po yung sinasubject natin to the machine. Okay? So, dito po, ang sasubject mo po diyan would be yung mga iti-test po natin na material. Okay? So, but then, principle po nito is the same lang po. Okay? So, you expose po the material na ito-test po natin okay, using the electromagnetic waves. Okay, so expose that to electromagnetic waves, so magkakaroon po tayo ng current out ng atin na sample. Okay, so para pong X-ray lang. Ang in-X-ray lang po natin would be a machine part or a machine component. Okay, what is its difference with this one? So you call it the film radiography. Okay, so ano po ang difference ito dun sa naunang radiography? Okay, so yung una po, sabi natin, it is most likely as X-ray. Okay, so yung X-ray. Ito naman po, radiography is more likely to be a copier. Okay? Para po yung copier natin, yung Xerox po natin. Okay? So, ang ginagawa po dyan, we have here po yung material po na gusto natin na i-test. Okay? And then you expose this again to radiation. So, makikita mo po dito, ito po yung output. Okay? Okay? So, ito po yung output. Nakikita mo po yung defects. Okay, on pertaining to direction, okay, Tapos po, ayan, so makikita po doon sa film na makukuha mo, okay, yung different types po ng defect ng ating material na tinetest po or component. Okay, so this one naman is called the pulse echo, okay? So, alin naman po yung katulad nito? This is very similar to an ultrasound. Okay, so sino po dyan nakapag-conduct na ng ultrasound? Okay, so halos parehas po yung ginagawa po dito. Okay, so this is our equipment po. Okay, connected to an oscilloscope. Okay, so this oscilloscope po, it provides a detector screen, flow detector screen. Okay, so ang gagawin mo po dito po sa ating equipment, you round this down to sa ating plate, okay, na tinetest for surface discontinuity. So, irarun mo po siya sa surface ng plate. So, for every time po, you would have yung test points natin. Alam mo, this is point 1, point 2, point 3. So, doon po natin itatapat yung atin na equipment. Okay? So, as it run down doon po sa atin na plate, makikita mo po yung reading dito sa atin na oscilloscope. Okay? So, dapat po yan, kung wala po yung surface discontinuity, so yung value po, okay, should be simply a horizontal line. Okay? So, horizontal line. Pero as you can see here po, may mga waves po tayo nakikita. Okay? So, ano po yung mga waves po na yan? These are the frequency na naka-observe po natin, mataas po yung frequency niya doon po sa parte kung saan may surface discontinuity. Kung saan po meron na crack, so mataas po yung value no frequency po no sound waves po dyan. Okay, so kung you have the plate po at hindi mo po alam kung nasa yung location nun pong atin na discontinuity, so you can easily track it po using this oscilloscope. Okay? So, makikita mo po, ay, nandun pala siya sa parte na iyon. Okay? Nandun pala siya kasi base doon sa naging result po ng iyong NDT. Okay, so this is another one. Okay, so we call this ultrasonic imaging. So, ano naman po yung counterpart po nito? Ito naman po yung scanner natin. Okay, so we scan the material, okay, or we scan yung component to see kung ano yung mga defects po na meron siya and its degree nung yung severity, okay, nung ating mga discontinuities po na yan or the defects. Okay, so you simply scan po the whole thing, the whole component para makita po natin yung defect. Okay, so this one naman po is the eddy current testing. Okay, so how do you conduct the eddy current testing? This is to detect again the discontinuity on the surface. And also, this can obtain the value of the conductivity of the material and the thickness of yung coating. Okay? Na ginagamit natin for the wires. Okay? So, paano po ba siya kinoconduct at ano yung kailangan? Okay? So, these are the basic component of your apparatus. Okay? So, ano po meron? We have the voltage source, we have the current meter, and we have here yung coils, okay? The electrical coils. So, yung mga wires po natin. And then, this coil po is to i-run po natin onto the material na iti-test po natin. Okay? So, isusuot po natin dyan, i-run po natin dito. Okay? So, every time po here, maglalagay po tayo ng set point. So, halimbawa po, itong dulo po, you make it as set point 1. Okay? So, it is point 1, tapos yung dito would be point 2, point 3, 0.4, 0.5 for example. So, hinahati-hati po natin. So, with these points po na sinet po natin, ang gagawin po natin, doon po natin itututok yung atin na doon po natin ilalagay yung atin na coil. Okay, halimbawa po, this is yung point 2. So, doon po natin ilalagay yung coil. And then with the voltage po na isusupply po natin, mame-measure po natin ngayon dito yung current. Okay? So, katulad po nito, it is pointing at a value 30. Okay? So, ibig sabihin, that would be the current on that particular position. Okay? On that particular point. Okay? Yun yung pong select point po natin. And then halimbawa po, you go to set point 4. Halimbawa po, ito yung set point 4 natin. That is nandun na sa tapat ng crack. Okay, ano nakita natin? The value, okay, nag-decrease na ngayon. Okay, so kung wala po yan na any discontinuity, the value po nung atin na current would be the same. Kumbaga, all throughout, it would be equal to this value 30. Okay? But then, because of the presence of the crack, okay, ng surface crack po natin, nakita mo ay may pagbabago doon sa value ng current po. Okay? Obtained from the testing. Okay? So, ganun po natin ngayon ma-locate yung kung atin na yung mali doon sa atin na setup, okay? At doon po natin madidetect nasan yung mga surface crack, okay? Base sa nakuha po natin na test results, okay? Okay, next one. We have what's so called the pressure test. Okay, so pressure test po naman, this is commonly done on pressure vessels. We have there yung mga tanks, pipings, tubings, yan. So this is commonly known po as the hydrostatic test. Okay, so this can use po either air or fluid. Okay, so minsan po, kung sinabi po natin fluid, it can be gas or a liquid. Okay, so commonly po, ang ginagamit natin dito is air o kaya po ay water. Okay, since the two are readily available. If we will be using po specialized fluid or liquid, okay, so mas mahirap po yan kasi mas magastos. Kaya nga po, ang ginagamit po dito mainly is air at saka po water. Okay, since yun po yung mas economical. Okay, so how do you perform the test? Okay, so halimbawa po yan. How do you perform the test? Halimbawa po, ito po yung ating pipeline. Okay, so ang gagawin mo po, i-constrain po natin yan. So, isasarado po natin. Okay, so ihihiwalay po natin sa system, tapos isasarado po natin. So, kung siya naman po ay pressure vessel, okay, so ganun din po. And then we put in po, say, air or water inside. Okay? And then, after po natin ma-fill, okay? After po natin malagyan, you take a look po at the pressure reading. Okay? So, they are equipped with pressure gauges. So, you look at the pressure reading. So, you take note of the initial value. Okay? Ano ba yung initial value? After filling it up with yung liquid, yung air, or yung water, okay? So, titingnan mo ngayon, ano yung resulting pressure, okay? So, after knowing the pressure, so, ino-note po natin yun. Ito take down po natin, okay? And then, with a time interval, so, halimbawa po, after a minute, okay, you again take a look or you measure again the pressure. O titingnan mo ulit sa gauge. After a minute, ay wala naman pong nabago. The same pa rin. And then after another minute, okay, so periodically po, okay, so at a required time interval, so titingnan mo, imo-monitor mo. Ano ba? May changes ba sa pressure na nangyayari? Okay? So, kung wala pong changes on the pressure na nangyayari, ibig sabihin, wala pong leak yung atin na system. Okay? Walang leak yung system. Pero pag tinitingnan mo po siya, so every time, okay, regular interval, so after a minute, ay nabago na po siya. After another minute, mas nabago po ulit. Okay? So, ibig sabihin po noon, nababawasan yung laman niya sa loob. Nababawasan yung mass sa loob, which again changes the pressure. Okay? So, yun po ang ibig sabihin po noon, meron pong leak po tayo doon sa ating system. Okay? So, you can detect the failure, okay, base doon sa test po na kinonduct po natin. Okay? So, you need not to destroy the material to see na merong failure. Okay? ano po nangyayari, base lang sa test, base lang sa data and monitoring na ginagawa natin. So, na-conclude po natin na meron pong mga defects. Okay, so this is another one. We call this the ferrite test. Okay, so this one is used to determine the quality of weld. Okay, so in particular, hinahanap po niya is the number of the ferrite content. Okay, so doon sa weld po, titinan mo, meron ba siyang tamang bilang ng ferrite. Okay, so paano po yan kinokonduct? Halimbawa po iyan, okay, ito po yung atin na dalawang cylinder tapos pinagdugtong natin using welding, okay, welding process. So when say i-weld po natin, melt po tayo ng filler material, so i-melt po natin tapos siya po yung i-fill in natin to close the gap. Okay? So, yun po yung nangyayari during the welding. Okay? And yung pag-weld po natin, there is a required number of ferrite, okay, na dapat po na ma-meet. Depende sa application. Okay? So, ano pong ginagawa dyan? So, you test the number of ferrite. Okay? So, you will be again setting set point. So, halimbawa po, simula po doon, okay, ito po yung 0.1. Tapos, regular interval po, i-mark mo po. Alam mo, ito yung 0.2, ano yung 0.3, 0.4, along the entire circumference. Okay? So, yung buong circumference po na hininangan po natin, lahat po ng area na hininangan natin, dun po tayo maglalagay ng set point. Okay? And for every set point po, dun po natin itututok yung ating probe. Okay? So, yung probe po ngayon, nakakonekta dito sa ating na screen, which will, okay, display yun pong ating ferrite number. Okay? So, yan po yung ililista natin. Alam this is 0.1. Magkano yung ferrite number? 55.9. Ari yung 0.2. So, dito mo itututok yung atin na probe doon sa 0.2 tapos reading ulit. Okay? So, dapat ilalagay po natin, i-collect po natin yung data. Set 0.1, what would be the number of ferrite? For set 0.2, 3, 4, and so on. Okay? So, after the testing po, okay, after you obtain the number of ferrite per set point po, so yun po yung i-evaluate natin. Okay? Lahat po ba ng data natin na nakuha pasok doon sa tinatawag natin na allowable value. Okay? O, ibig sabihin po, tama po ba yung bilang ng ferrite all over na in-applyan po natin ng welding. Okay? So, kung hindi po, okay, nakita na, ay, bagsak dito, kulang po dito. Okay? So, ibig sabihin, you need to have, okay, you need to have po yung proper, okay, procedure on how to rectify the problem. Kung kulang po siya, ano kaya yung pwede kong gawin? O kung labis siya, anong pwede kong gawin? Okay? So, you should only meet what is required. Okay? You should meet what is required.
Pinumatay na yun. No? Yun yung nag-require nga dati. Ganyan ba kayo?
Okay, this is the common application of the so ito na po natapos yung mga samples po ng NDT. Okay, and then the brief description of each of those process. So what are those common application of non-destructive testing? Okay, so first one is inspection of the products or raw materials. Next is inspection following secondary processing. And then last is in-service damage inspection. Okay? So, paano po nagkakaiba-iba? Ito po yung tatlo po na ito. Okay? So, we'll start with the first one. Okay? So, NDT is used for inspection of raw products. Okay? So, we refer here as the raw materials. Okay? Halimbawa po, we are to create yung glass bottle natin. Okay? So, what would be its main ingredient? What would be its raw material? Okay? So, you have there yung silica. So, anong gagawin po natin doon? Siya po ating susunugin. Okay? Tapos, tsaka po natin ilalagay sa cast. tsaka po natin siya i-form. Okay? So, on this particular stage po, inspection of raw products, ang gagawin po natin, yung raw material mismo, okay, yun na po yung kina-quality check agad. Okay? Iko-quality check mo using the NDT. Okay? So, sa simula pa lang, ina-apply mo na agad yung NDT. Okay? Para the operation would go on. Okay? So, yun po ay before this forming processes. Okay? So, you call this deforming processes. With what you have given po ay with the raw materials po, okay, na initially should be inspected, okay, yun po ngayon yung bubuuin natin using any of these methods, okay, or kung alin po yung applicable. Okay, pero maliwanag po, the inspection is done on the raw materials, okay, before you do the forming processes. May tanong po sila?
Wala naman po.
Okay, this is the second one. Inspection following secondary processing. Okay, so kanina, what we inspect is the raw material. Okay, so this time naman po, it is the process, it is the secondary process. Okay, so what is inspection following secondary processing? So that involves machining, welding, grinding, heat treating, and then plating, etc. Okay, so these are the secondary process. So, ibig sabihin po, after po natin na mabuo yung component using, for example, the casting or the extrusion, okay, ang gagawin po natin, again, we will be subjecting this to secondary processes. Halimbawa, nung inalis natin doon sa mold, okay, nung inalis natin sa mold yung component, okay, makikita mo sa mga tabi parang may mga flashes, okay? So, may mga labis-labis na parts, okay? So, ang gagawin po natin, these flashes, okay, pwede po yan na gupitin, okay, para ma-retain po yung shape lang ng component or equipment, okay? So, ang gagawin lang po is to, gupitin yung mga flashes po yun, okay? Or you can do also heat treatment or grinding, machining on these components, okay? So, yan po yung tinatawag natin na secondary processing, okay? And then the last one is inspection for in-service damage, okay? So, in-service damage naman po, meaning as ginagamit mo po siya, habang ginagamit mo siya, what are the inspections that can be done, okay? So, the first one is you look for, okay, the cracks, okay, yung erosion wear, heat damage, okay? So, titingnan mo, okay, maigi yung iyong component, okay? Meron na ba siyang mga symptoms, okay, nung mga damages na ito on the material, okay? Okay, so yun po yung tatlo, okay, na mga applications po niya. Ano naman po itong mga kasunod na ito, okay? So dito ba kanina, may pinakita ko kanina na areas, okay? So, yung areas po natin, okay, na are industries that make use of the NDT. So, nakita nga po natin doon yung sa mga industry, we have the aerospace, the railroad, okay, the power plant. So, yan po yung mga industries which are engaged, okay, doon sa NDT. Okay, so this is po yung mga specific examples po natin. Okay, so for example po, this one is for a power plant inspection. Okay? So, how do you inspect po yung atin na power plant? Okay? So, minsan narinig natin ay may shutdown. Okay? So, ano ibig sabihin ng shutdown? Okay? You need na itigil po. Okay? You need po natin na itigil yung power plant, yung operation niya. Okay? para po wag tayong malugi. Okay? And also, you can have there the substitution, okay? Or you can have there yung shutdown due to inspection. Okay? So you need to inspect everything. You need to inspect all parts of your power plant, okay, to do the uh, okay? So, ito po yung ating tinatawag na power plant inspection. Okay? Say, ang gagawin po natin saan, okay, example po natin dito, this is your condenser or boiler. Okay? So, kung ito po yung boiler, sa loob po ng boiler ay napakadaming tubes. Okay? So, ito po yung mga tubes na yan ng boiler. So, napakahirap po niya na linisin. Okay? So, napakahirap po linisin kasi skills are accumulated doon po sa atin na nasa loob na parte. Okay? So, here po, doon sa sample po natin, kung ito po yung ating boiler, so it is composed of several tubes. And you need to detect alin sa mga tubes na ito ang merong sira. Okay? Bakit may leak? Okay? So, you will have your test probe po. Okay? I-run po natin on each of this condenser. Okay? So, i-run po natin. So, base sa result po dito, doon po ma-identify kung meron defect on the material. Okay, this time naman po, it's on the wire rope. Okay, so ito na po is under the transpo. Okay, so we have here the wire rope inspection. Okay, ito po yung sample natin. Okay, so sample po niyan is the cable car. Okay, so of course, there is a friction between yung pong handle ng cable car at saka po yung ating wire rope. Okay, so due to wear, okay, pwede po maging ganito yung ating wire rope, okay? So, naninipis po, tapos, anong nangyayari? Napuputol, okay? So, ano po yung pwede natin gawin para po ma-decrease po yung ganyan na mga cases, okay? So, you do inspection dito po sa iyo na cable, okay? Yung iyong wire rope, okay? So, you do the inspection. And it is a regular check up po of these wires, okay, regular inspection. Hindi po pwedeng isa lamang tapos yun na. Okay, you need to monitor, okay, you need to monitor the operations, okay, nun po atin na material. Okay. Okay, storage tank inspection. Okay, so dito naman po, on the storage tank, okay, so there are several tanks of different sizes. So, these tanks po, these are to be inspected, okay, so as to see yung mga defects on these big components, okay. So, there are robotic crawlers that are used to ultrasound the walls and yung mga tanks natin, okay, na parati natin na ginagamit, okay. So, katulad po nito, kung napakataas po ng atin na equipment, so, hindi po natin siya kaya abutin lahat, okay. So, our solution is to have these robots that will cling hanggang doon po sa pinakamataas na parte. Okay, so in that way, okay, so nasa-save po natin yung environment, okay, so we do not makikita po natin ang defects using the robots, okay, so na-articulate po natin. Okay, so this time naman po, this one is on the aircraft industry. Okay, so sa aircraft naman po, okay, so it is subjected yung aircraft natin kung nasa himpapawid po siya. So napakataas po doon ng pressure. Okay, so you take a look po doon sa pressure nung sa atin na aircraft. Okay, yun po yung dapat natin tingnan. With that amount of output po, okay, ano naman po yung degree ng naging damage. Okay, so say for example po, katulad po nito, okay, this is taken a year ago, okay, wherein Okay? Wherein it is the body of the aircraft, tinamaan po ng ano po natin. So, yung pong ating body, tinamaan po nung atin na lightning. Okay? So, nung tinamaan po siya ng lightning, ay nawala ako. So, nung tinamaan po siya ng lightning, ano po nangyari? You have here po the condition. Yan. So, makikita nyo po, tinamaan po dyan, then nag-propagate na po yung ating nakalak. Okay? So, yan po yung dapat natin na mawawanta. Okay? So, you have here now po, okay, the degree of the, ano po, the discontinuity, the surface discontinuity, and then you can compare that po with the standard. Okay, you can compare that with the allowable value. Okay, so if it's within the allowable value, you can have yung solution natin. Okay? You can have the real value ng atin na sagot. But then, kung ano naman po, okay, we need to rectify once you have located these damages. Okay, so this is jet engine inspection. Okay, so this time naman po, it's the engine of the aircraft. Okay, hindi lang po yung body. Yun po yung ating na check. Okay, that's the jet engine. So this is her jet engine. So ano po ang ginagawa? Dinidisassemble po yan. So pinaghihiwa-hiwalay po niya. At then bago po yan na disassemble ay dapat make sure yung nagkalas po ay siya rin yung magbabalik at alam po kung paano i-assemble po ulit. Okay? So these engines, they are disassembled. Okay? They are cleaned and then being inspected tsaka po ibabalik into the uh, final form. So, i-reassemble po natin ulit. Okay? And then fluorescent penetrant inspection is used to check many of the parts for cracking. Okay? So, not sure of the last clause po natin. Okay? As to this jet engine. So, ang ginagawa po dito, so, hinahanap po dito sa parts na ito, yun po, surface discontinuity. Okay? So, yun po yung nangyayari po dyan. Okay? So, the engine needs a total overhaul. Okay? Para po sa pagpapalit po nito. Okay? Yan. Okay, so this is one incident that happened in Iowa in 1989. Okay, wherein you have there the disc of the engine. Okay, and this disc of the engine, ano pong uh, yung disc po na yan, this may contain the surface discontinuity or say yung crack po natin. And kung hindi po yan napansin, okay, pag po dinala natin under operation, so again, may expose na naman po siya sa mataas po na pressure, okay, and then that could ruin the entire material, okay, kasi nga, hindi siya na pag join, okay, and then also, hindi early na-detect po yung atin na defect. Okay? So, dapat po kasi there should be a regular interval. Okay? Nung pag-inspect ng ating mga component. Okay? So, this one is on the pressure vessel inspection which makes use of radiography and ultrasonic testing. Okay? So, yun po yung ginagawa along the walls, okay, of your pressure vessel. So, dyan po, tinitingnan natin is, say, for example, yung corrosion, gaano ba kakapal na yung corrosion na meron. Okay? So, with this corrosion po, ang nangyayari, yung thickness po ng entire material po natin para sa vessel, yun po yung kinakain ng kalawang. Kaya, numinipis po siya na posible pag sinubject po siya sa mataas na pressure ay
Hello po, ma'am. Hindi po kayo naririnig kanina. Ma'am, wala pa rin pong audio ngayon. Ma'am, excuse po. Nagsasalita po ba kayo right now? Wala po kaming naririnig po na audio ninyo. Dun po nag-stop, ma'am, ang audio nyo po sa dito po sa wire rope inspection.
Hello, naririnig na.
Yes po, ma'am. Nga ngayon lang po ulit kayo nagka-audio po.
Ay, bakit hindi kayo naimik? Natapos ko na yung module, ha? Bakit hindi kayo nag-message man lang dito sa ating chat box?
Sorry po, ma'am. Akala po namin ay nadisip po kayo kanina.
O yan, saan tumigil kanina?
Ayan dyan po ma'am, sa wire rope inspection.
Natapos ko na po ito kanina, wala man lang na nagsabi sa inyo. Okay. Okay, so heist. Okay. So we have here storage tank inspection. Okay, so there are cases that the power plants, okay, merong yung storage tank which are really very large. Okay, so through the visual inspection, so hindi po natin talaga mamomonitor yung atin po na operator, okay, and may inspect lahat ng parte. Okay, so we do have what we call the crawlers, okay, that runs through the entire po na storage tank po natin, which is equipped with camera, okay, so to see yung degree na corrosion sa loob, so as yung po mga scales, okay, coming from the fluid na nakastore po doon sa mga tanks po natin, okay, to see really if there are defects, okay, on the storage tank. Okay, here naman po is the aircraft inspection. Okay, so yung aircraft po natin, okay, as it moves po, okay, so it is exposed po to high pressure, and also there is a tendency po that it could be with a lightning strike. Just like this one po, ito po yung tama ng lightning, okay, doon po sa body ng ating aircraft, okay. So these are regularly inspected, okay, the body, the entire aircraft is regularly monitored, inspected, kasi yung pong ganyan kasimple na crack, okay, kahit po maliit lang yan, if you are to expose that to a high pressure po, maaari po agad dumaki and cause po ng severe na damage. So we have here jet engine inspection, okay? So yung engines po ng ating aircraft, they are overhauled, okay? After being serviced for a period of time, okay? So meron po talaga silang schedule ng inspection. So dinidisassemble po yung ating na engine, okay? So after it is disassembled po, it is cleaned and then inspected. So they make use of liquid penetrant po, kasi pag tinignan nyo po lang po na ganyan, mukha namang makinis after being cleaned. So parang wala siyang mga cracks or any other flaws. So you expose that to yung liquid penetrant inspection para makita really yung mga damages. Okay, so after you've seen the damages, gaano man po kaliit, it would be rectified, it would be repaired, tsaka ulit i-reassemble, tapos tsaka po ulit ilalagay doon sa atin na aircraft, okay, para magamit po ulit. But then, once po na may nakita kahit po konti dito sa mga parts po na ito ng atin na engine, so yun po ay hindi muna i-assemble. Okay, it needs to be repaired first, okay, at i-rectify po. Okay, so that is the cause. Okay, yun po maliit na defect na po yun, yung crack po na yun on the engine disc. That is the one responsible for the crash of the aircraft in Iowa in 1989. Okay, so yun po yung nakita. May maliit na, may defect na damage doon sa atin po na engine disc. So, napakaliit lang po na crack, but then sabi nga po, if you are to deploy that po doon sa environment with a severe condition, napakataas na pressure, so ang tendency po niyan is mag-severe din yung ating na defect po niya. This is pressure vessel inspection, okay? So for pressure vessels, okay, they are inspected as to the corrosion, yung build-up ng corrosion, yung pong scales, okay? And they make use of the radiography and the ultrasonic testing, okay? So yun pong thickness po dito, after po na maalis po natin yung corrosion, so yung thickness po all throughout would be measured, okay? So titignan po, the same pa ba yung thickness? Mukha kasi meron ng parte na sobrang nipis na, so it needs to be rectified, okay? Kasi pag i-subject that again to mataas na pressure, so possible po na doon po magkaroon ng failure.
O, pero may concepts na sila ng time and space.
Okay, rail inspection. Okay, so you have there the railway. Okay, so sorry. So this is the railway for the train. Okay, so that is also monitored using the special cars. Okay, so special cars, these are cars that runs through the railway. Okay, para po ma-check natin yung mga discontinuities on the railway. So these are equipped with camera, okay, and sensors para po ma-detect po yung mga failures po na yan. Bridge inspection, okay? So bridges, these are inspected, okay, every 2 years, okay? So they do have the visual inspection every 2 years, but then there are special cases na kapag po nagkakaroon ng natural phenomenon such as yung typhoon po o kaya po ay earthquake, okay? So mas dumadalas po yung inspection na kinukonduct on these bridges, okay? So modern bridges, they are equipped with what we call acoustic emission sensors, okay? So using the sensors, okay, so yung sound po na nakikreate of the propagating cracks on these bridges, okay, yun po yung binomonitor, okay? Yun po yung tinitingnan as to degree ng kanilang severity po nung defects po na yun. Okay? So, napipredict po yung failure, okay, because of yung monitoring, okay, nung pong ating sound, nung propagating cracks. Okay, this one naman is for the pipeline. Halimbawa po, this is our pipeline. Okay, so you have there, mahaba yung pipeline natin. Okay, so you have there the robotic roller. Okay, na siya pong pinapa-inspect natin yung loob ng atin na pipeline. Okay, so again, this is equipped with camera and sensors that would monitor yung conditions po ng atin na pipeline. Okay, and then also they perform radiography on the welded joints. Okay, because these welded joints, yan po yung mas posible na failure would occur. Okay, because it becomes the weakest part of your pipeline. Okay, doon sa mga parte po na pinagtugtungan. Okay, kaya they perform radiography as to yung quality ng weld. Okay, kung nagkaroon na po ng corrosion, so tinitingnan po as to yung quality po niya and so as the number of ferrite. So all of those were performed using the NDT methods. And then last one po, you have here po yung bell po natin, okay? So this one naman po is used for educational purposes, okay? So you have there the failure po ng bell, nagkaroon ng crack when an incident of an earthquake happened, okay? So dito po, an electrical conductivity test is run na nag-set points po dito sa atin na Liberty Bell in Philadelphia. So the value of the electrical conductivity sa any point po dito, they are being measured. And to the and they observe that dito po sa parte na meron po tayo na surface discontinuity, the value of the conductivity varies. Okay, so dito po meron magbabago sa value over the other parts of the bell. Okay? Okay, so yun lang po yung applications of this NDT. Okay, so I am done with you the ano po, module 5. Okay, so for your review, you take a look again on these parameters. What would be the purpose of this test? Okay, mechanical test, whether it's destructive testing or NDT. Okay, what are those specimens that are used? The defects na predict po using the test, what would be the cause, okay? So you can have the comparison between the cause and particular examples for each of the test. O, naririnig pa po. Hello?
Yes po, ma'am. Rinig.
Okay. Okay, so you have here our module 5. Okay, so this would be yung last part po, okay, last topic for our midterm examination. So may question po ba sila? Hello? Wala na?
Wala naman na po.
Okay. So paki-check na lang po yung ating yung ating classroom kung alin pa pong mga modules ang hindi ko pa po na-upload, okay? So that I could have it uploaded for your review, okay? So again, yung pong ating examination would be by next week, okay? Ito po yung hanggang dito po sa module 5, yun pong ating topic, okay? So the midterm exam is composed of 100 points, okay, divided as two, yung may objective part po at saka po yung problem solving. Okay, so objective 5 po, pwede po siyang identification, enumeration, essay, or any other form of objective type questions. Okay, so make sure po you are available during the scheduled date. Okay, because I do not give a special examinations. Okay, so make sure you are well and good during the exam. Okay, you know the rules po. Okay, so hindi na po natin kailangan isa-isahin pa ulit iyon. Okay, so you apply it on our examination. Any question? Miss Janella?
Yes po, ma'am.
You submitted to me your tama ba? Yung
Yes,
nandito sa table ko.
Apo.
Ilan-
Mayroon lang
il-
pong
Ilan po
output
yun?
na na-
Ilan yun?
42
Hindi,
po.
I mean activity. Ilang activity?
Activity 2, 3, and 4 po.
So 2 and 3 and 4. Okay, so
Yes po.
kapag po na by next week po, you bring here po yung expandable folder, okay, for the group. Okay, so ilalagay po natin per activity. Nakuha mo, Ineng? Hello?
Okay po. Ano pong
Okay.
may specific po bang kulay po ng expandable?
You can bring yellow siguro. Wag lang po red, blue,
Okay.
and green. Okay? Kasi ang nandito is red, blue, and green na. Okay? So, a different color for your group.
Bali, isa lang po. Doon na po lahat ng activities
Hindi.
for
It should be one per activity.
Okay po.
Okay. But then for the whole na po yan? For the whole class. So I'll stop now the presentation. Kindly check na lang po yung ating na classroom. Pakiulit na lang po sa akin kung ano yung kulang para may upload ko po. Okay? And then, yes po.
Ang uploaded na po sa G-Class, ma'am, ay module 1 to 4 po.
Okay, so ang kulang na lang po natin is the module 5. Okay, sige po. Na lang po, open po ako ng camera for our attendance and documentation. Okay, so next time po pag na-disconnect ay mag-message po kayo sa GC para po hindi ako mag-ulitan. Okay? O, ang haba po ulit nung inulit ko na yun. Wala kasing naibig sa inyo. All the while I thought ako'y tapos na. Yung pala ay na-disconnect na. Akala nyo na-disconnect. Okay? So, how about our attendance, Miss Janela?
Okay po. 1, 2, 3. Wait lang.
Okay, another one po, lagay mo na lang doon sa GC po natin para doon na lang natin kukunin lagi yung attendance.
Isa pa po. 1, 2, 3.
Okay na?
Okay na po.
Okay, sige po. Thank you. Bye.
Thank you po.
Thank you po.